Hello everyone, and welcome back to our SQL training series. In today's video, we'll go through question 45, how to identify customers whose gap since the last order is greater than their largest historical gap between orders. We'll understand the business requirements, look at the dataset, and then dive into two different SQL solutions step by step. We're working with the orders table, which contains information such as customer number, product number, and order date, etc. There's no primary key in this table, and each row is basically a sales record. Order dates are stored as floats in YYMMDD format, so we'll need to convert them into proper dates before doing calculations. Here's what the business wants. For each customer, we need to find the largest gap in days between two consecutive orders. Then, we also calculate how many days have passed since that customer's last order up to a fixed date, April 17th, 2024. Finally, we only return customers where the days since their last order is greater than their largest window. The output format looks like this. Let's see the solutions in SQL Server Management Studio. Solution 1. Using window function lead. Let's go step by step. The first common table expression CTE takes order date, which is stored as float in YYMMDD format, converts it into a proper SQL date. Use distinct to avoid duplicates if multiple orders happen the same day. The result is a clean list of customer with order date. The second CTE, we use the lead function to look ahead to the next order date for each customer, partitioned by customer, so each customer is treated separately. Then calculate days between orders. We subtract order date from next date to get the number of days between consecutive orders. Excludes the rows where next date is null, customers with only one order, or the very last order of each customer. After this step, we know all the gaps between consecutive orders for each customer. The last common table expression calculates the maximum days between orders, and also days from their last order to April 17, 2024. For each customer, max, days between, finds the largest historical gap between two orders. Max, order date, finds the latest order date. Datediff function calculates how many days have passed since their last order up to April 17, 2024. The main query filters only customers where time since last order greater than their biggest past gap. Therefore, the query is identifying customers who are overdue, i.e., their current inactivity period is longer than their historical longest inactivity gap. Solution 2. Using dense rank. This approach is to use ranking to explicitly join each order with the next, with only two CTEs. The first one rank orders per customer. We assign a dense rank to each order per customer, ordered by date. The second one self-join consecutive orders. We join each order with the one that has RK plus 1, so we get pairs of consecutive orders. Finally, we aggregate results in the main query, calculating the largest gap and the days from last order, just like in solution 1. Both achieve the same result. Identifying customers whose gap since the last order is greater than their largest historical gap between orders. However, based on the performance, we can see solution 1 is faster. That's because lead is a window function. It only needs to scan the partition data once per customer and directly returns the next row. Dense rank itself isn't the issue in solution 2. It just numbers rows. But self-join has to pair up every row with the next row. This effectively doubles the amount of work. Scanning, ranking, and then joining across the dataset. Practical recommendation. Always use lead or lag when you need next row or previous row logic. To wrap up, this is a real-world use case of window functions. Very useful in analyzing customer activity, churn detection, and purchase frequency. Thanks for watching. If you found this video helpful, please like, comment, subscribe, and share this channel. Thank you.